Hey everyone, so this is our last and final method that helps us to find the axis of symmetry and the vertex, okay? So this is probably the easiest method to use, but I'm going to show you where it comes from, okay? So we're going to be using a formula, and we're going to derive that formula in this video. So, what we know about the axis of symmetry. The axis of symmetry can be found through that intercept method. So it is the midpoint of the x-intercepts. So let's use that fact to find a general sort of equation for it. Okay, so our general solution to any quadratic equation is just using the quadratic formula. Okay, so generally we can find all x-intercepts using the quadratic formula. So let's write that quadratic formula out, but let's write it for x1 and x2. Okay, so our x1 is just going to be the positive version, so it's going to be negative b plus the square root of b squared minus 4ac all over 2a. And then our next one is going to be our negative version, so negative b minus the square root of b squared minus 4ac all over 2a. Now, the midpoint of these two can be calculated as follows. It's going to be x equals x1 plus x2 over 2. Let's substitute the quadratic formula. It's going to be a bit messy, but let's work with it. It's going to be negative b plus the square root of b squared minus 4ac all over 2a plus negative b minus the square root of b squared minus 4ac all over 2a, and this is all over 2. Okay, so let's try and combine these together. At the top, they have the same denominators, so we can add them together. So it's going to be negative b plus the square root of b squared minus 4ac. Well, it's going to be plus minus b minus the square root of b squared minus 4ac. And this is all over 2a, and then that's over 2. Okay, so this equals, so negative b, that's going to be negative 2b. Then this is going to be plus the square root of b squared minus 4ac minus the b squared minus 4ac. So let's highlight this. This and this becomes this. And now this plus minus this, that becomes 0 because they cancel each other out. Okay, so that's going to be negative 2b over 2a, and then it's going to be over 2. Now that over 2 means that this is going to be divided by 2. Okay, so let's do that. Let's divide this by 2, which means that we are timesing by the reciprocal of that, of 2, the opposite of it, which is 1 over 2. Okay, now this is going to be negative 2b over 2 times 2, which is 4a. So our final is going to be 2 over 4. That cancels if we simplify it. Yeah, we're going to divide the top by 2, which is 1, and we're going to divide the bottom by 2, which is 2. Okay, so it's going to be negative b over 2a. This is our formula for the axis of symmetry. Okay, so make sure that you have this formula in your books to reference to when you're doing the questions. Okay, let's go through an example just to make sure that we understand what we're doing. Okay, so what is the equation of the axis of symmetry? Part A. for y equals x squared minus 6x plus 4. Now, using the formula, x equals negative b over 2a. Or was it negative? Yeah. Negative b over 2a. We just substitute our b, which is our coefficient of x, and our a, which is our coefficient of x squared. This is going to be 1. Okay, so a equals 1 and b equals negative 6. And let's put that in. So x equals negative 6. So it's going to be negative 6. Okay, over 2 times 1. This is going to be negative becomes a positive. It's going to be 6 over 2, which equals 3. So our axis of symmetry is x equals 3 is the axis of symmetry. Okay, so that's how you find the axis of symmetry using the formula. A lot easier, isn't it? Okay, now our part B is, at what point does this axis of symmetry cut the parabola y equals x squared minus 6x plus 4? Now let's think about this. So if I was to just draw a parabola, and our axis of symmetry is going to be right down the middle, where is it going to cross that parabola? Okay, so where is it going to cross this parabola? Well, it's going to cross right here. I'm going to make that black actually. Okay, which is your vertex. So this is part B, is just a different way of saying what's the vertex. Okay, so B, they cross at the vertex, and it wants us to find that point. Okay, so let's find that. So we know our x value is going to be 3, but what's our y value going to be? Well, we need to substitute x equals 3 into the equation. Y equals x squared minus 6x plus 4. Okay, to find that y value. So y equals 3 squared minus 6 times 3 plus 4. Okay, so this is going to be 9 minus 9 plus 4. That cancels out. So y equals 4. Okay, so therefore the axis symmetry crosses the parabola at the point 3, 4. Okay, this is also the vertex. Okay, so the vertex and the axis of symmetry always have that in common. Okay, now part C, I'm going to add another page. So part C is, where does the parabola cut the y-axis? Okay, so there's an easy way to see this. Where does it cut the y-axis? Well, what's the y-intercept? Well, the y-intercept is our constant, our plus 4. Okay, so part C is the parabola crosses the y-intercept at 4. And that's just from the equation, coming from the equation. Okay, and then lastly, part D is sketch the graph. Okay, so let's draw this. This is just a sketch, so please Forgive me for not doing straight lines. This is our x, this is our y. At x equals 3 is our axis of symmetry, so let's do 3 here. Our vertex is going to be at 4, so that's going to be up here. 4, drop the point there, and it's going to cross our intercept. Oh, 6 times 3. I apologize. 6 times 3 is 18. So 9 minus 18 plus 4, that equals minus 5. I apologize, this is minus 5. Okay, so that makes more sense because it can't go through the intercept. So minus 5 is all the way down here somewhere, and that's going to be here. So is it concave up or concave down? Well, x squared is positive, so it's going to be concave up, and it's going to go through this point here. So it's going to be like this, and then because it's symmetrical, it's going to be the same on the other side. Okay, so that's what the sketch would look like. This is what y equals x squared minus 6x plus 4 approximately looks like. Okay, we don't have the x-intercepts to confirm where it crosses the x-axis, and you can totally find that, but we haven't been asked to do it, so we've drawn it like that instead, with the vertex in mind and our y-intercept. Okay, so have a go. Good luck.